Okay, so this video here we're going to work on finding inverse functions. We're actually finding them. We're not verifying that two different functions are inverse functions. We're actually taking a function and finding its inverse. We have steps here. We use the horizontal line test to see if f has an inverse function. Do that first. Once you are in the equation, replace f of x with y. After you do that, change the x and y's around. Interchange x and y. And then solve for y. And after you solve for y, we're going to replace it with the notation of inverse f of x. Okay. Now, I've actually done this already. I have 5 minus 3x over x plus 2. I have to have those in parentheses, by the way, if you're going to use your TI-84s. And then the graph looks like this. And the horizontal line test, you'd only hit it once here, you'd hit it once here, once here, once here, and so on. It is going down, but it does have a horizontal asymptote at -3. And what that means is it approaches -3 from this side. It keeps getting up and closer, and keeps going down toward -3, but on the top side of it. So at -3, when x is or y is -3, it is not going to touch either way. So you're still safe, and on this you'll be hitting only once also. So it does pass the horizontal line test. It's kind of tricky, but it does do that. Now, you can see I kind of started this and then decided I wasn't going a very good route there, so I decided to start over. But on example 1, we're going to find the inverse function of f of x equals 5 minus 3x over 2. So I'm going to write y equals 5 minus 3x over x plus 2. I think I said just over 2, but over x plus 2. Now, now that I've replaced f of x with y, I'm going to switch the x and y around. So now I've got, this leads me to x equals 5 minus 3y over y plus 2. Okay, let me just write that down here over again so I have room to do stuff to it. Now, I'm solving for y. I got y in two places, so somehow I'm going to have to deal with that. But what I want to do first is, let's not deal with the denominator. Let's multiply both sides by the denominator over here. And here, x times y is xy, and 2 times x, that's 2x. The y plus 2's will cancel, so that is equal to 5 minus 3y. We are solving for y, so let's get the y terms on one side. Let's add 3y to both sides. xy plus 2x plus 3y equals 5. Let's cancel. I'm going to subtract 2x from both sides. I've got xy plus 3y equals 5 minus 2x. Okay, so now I've got y's in both terms. I'm going to take y as the GCF here, and I have x plus 3 here equals 5 minus 2x. I will divide by x plus 3 on both sides because I am solving for y here. So I have y equals 5 minus 2x over x plus 3. And then my last step is the inverse f of x is equal to 5 minus 2x over x plus 3. All right. So, and I did want to talk a little about the domain. The domain of f if you look here, x can't be negative 2. Okay? Domain of f, if we we'd go negative infinity to negative 2, and then negative 2 with the curved brackets is non-inclusive to infinity. So that's how we conclude that. Now, the range of f, let me save that for a little bit. The domain of the f inverse, if you'll notice, we can't have negative 3 here. And if you'll look at this, so negative infinity to negative 3, negative 3 to infinity. That is what the range is. And if you remember the graph I told you, we have this line that if I have this horizontal line at negative 3, this will not touch either way. So the range of f is the domain of its inverse. So negative infinity to negative 3, and then negative 3 to infinity. The range of the inverse is negative infinity to negative 2, or negative 2 to infinity. Okay? The domain of f is equal to the range of the inverse. The range of f is equal to the domain of the inverse. And I don't know if you saw that or not. Okay. Example 2. Find the inverse of f of x equals the square root of 4x minus 7. Okay. Let's clear this. Let's take the square root of 4x minus 7. Let's graph that. Okay. We can see it would pass the horizontal line test. It just goes in that direction. The domain of f of x. Okay, I'm going to just do a little solving here, and then we'll work on the inverse here in a second. But if you remember, 4x minus 7's got to be greater than or equal to 0, which means 4x is greater than or equal to 7, which means x is greater than or equal to 7/4. And I think if we played around with that enough, that point right there, that end point, is actually goes to the line at 7/4, 0. That's like the starting place on this. So the domain of f of x would be, square bracket, 7/4 to infinity. And the range of f of x would be, I said it goes down to 0, inclusive, and it will rise without bound to infinity. All right, well, let's find what the actual inverse is. So y, I'm taking the f of x out and putting y in its place. It's 4x minus 7. Okay, let's switch these around. Take the x here and the y here. Square root of 4y minus 7. And let's solve this thing for y. So I'm going to square this. and square that. So I've got x squared equals 4y minus 7. X squared equals 4y minus 7. I'm going to add 7 to both sides. And x squared plus 7 equals 4y. So I'll divide this by 4. And I got y equals x squared plus 7 over 4. Now, if I were to type that in, let's see, x squared plus 7 divided by 4. Okay, now keep in mind, oh, I didn't put that finished touch on it. Inverse of f of x is equal to x squared plus 7 over 4. I want you to keep something in mind here, that this stops here, this starts here, that this is not part of it, because the domain of the inverse function is the same as the range. It goes from 0, so it doesn't start until here, 0 to infinity. This part is not part of the inverse function, because our domain is the same as the range here. Alright, and ooh, I'm going to have to wash that off. And then the range of the inverse function, that point right there is 1 3/4. Starts here and just keeps going up. Okay, and if you think of y equals x going right in between those two, and that's reflecting in that. But there's nothing in the second quadrant. That second quadrant isn't part of the function at all. Okay. Let's do one more for the good of the order. Example 3. Find the inverse of f of x equals the cube root of 10 plus x. Alright. I'm going to clear this one, and let's just look at the horizontal line test to see if it works. So, it's the cube root. Is that in the math? Yep, number 4 here. Cube root of 10 plus x. If I look at the graph of that, it continues to rise. Let me zoom out a little bit, because I think there's more stuff over here. I'm going to just change the window. Let's go negative 20 to 20 on the x's. And I don't think I need to change the y's any. Let's look at the graph here. Okay, so it has this kind of bend right here at negative 10, I might add, because negative 10 plus 10 is 0, cube root of 0 is 0. So it bends right here, but I think a horizontal line will only hit it, any horizontal line will only hit this graph once. So it passes the horizontal line test. Let me put y in place of f of x and write the cube root of 10 plus x. And then switch x and y around. And I got x equals the cube root of 10 plus y. Now let's solve this for y. First thing I'll do is raise this to the third power on both sides to get rid of the cube root. So I have x equals x cubed, equals 10 plus y. I'll subtract 10. I got x cubed minus 10 equals y, so my inverse function notation is x cubed minus 10. Let's take a look at that graph. Oh, x to the third minus 10. Let's get that graph. Oh, okay. I know what's wrong here. You get, if you highlight on here, you can get the kind of line you want. I want just a regular line, so I just keep hitting enter. If I hit enter again, I can get a dark line there. Let's do that. Let's see what that looks like. Here's the function, sf of x, and here is the inverse function coming up here. I'm going to change the window a little bit. Now I am going to change the window on the y's and go negative 20 to positive 20, and look at that graph. Okay, I do want you to consider that if I were to look at y equals x, how that is a reflection right there. It's kind of hard to see on this. Probably look a little more obvious on Desmos, but those are reflections. And so that's all I've got for you here.